Hey guys, this is 3C Centrifugal Force, the famed fictional centrifugal force here. So it says we got a dump truck is making a very fast left turn as shown. In the back are two blocks of ice, one of mass capital M and one of lowercase m, where capital M is greater than lowercase m. And the truck doesn't roll over as it makes that turn there. So first thing it says, sketch the paths that the left and right mirrors take during the turn. So this is basically to give you the path that the truck itself is taking. So the left mirror is going to start right there. It's going to end right there. And as best I can, I'm going to draw that path like that. So it's taking this circular path right there. And then the right mirror starts right here and it ends right there. So it is also going to take this circular path right there. So that is the path that the truck takes there. So next part B says, let me bring this down here for a second, that using two different colors, sketch the paths that the two blocks of ice take during the turn. Assume that the friction between the bed of the truck and the ice may be neglected. So there's no friction on these two blocks of ice here. So if there's no friction, then there's no force. According to Newton's first law, they will travel in a straight line. So this block will travel like this, the large block here. And then the other block, got to use two different colors, they said to do it. The smaller one, I'm not entirely sure why in this problem they even have two different blocks. I feel like they had something else planned originally and then just abandoned it. But anyway, so here we go. The two blocks want to continue on in a straight line according to Newton's first law. Objects in motion stay in uniform motion. Same speed, same direction there. So next part here, coming back to part C, it says, your friend who is not in physics class, doesn't know their physics, says the blocks go to the outside of the truck because of a centrifugal force that is acting on them. In a few brief sentences, explain why your friend is incorrect. Reference the diagram in your answer. So your friend thinks that the blocks were pushed to the outside of the circle. But we can see here that that's not the case. It's actually the truck that turned into the path of the blocks. So the blocks were going straight and the truck turned into them. So there was no centrifugal force. There was nothing that pushed the blocks out. They were continuing straight and the truck itself was pushed in by friction there. So next part D, it says the truck then approaches another intersection to make a turn. The truck can either make a left turn or a right turn as shown in the diagram. Well, they show you this diagram, but we actually don't need this picture until later, so we don't even need that. Here's the key here. It says the centripetal force for the turn is provided by the force of static friction, which is determined by the relationship force of friction static is equal to the coefficient of static friction times the normal force. So in a few short sentences, explain why the force of static friction and not kinetic friction is exerted on the truck, even though the truck is in motion there. So to sort of show that, let me move this off here and imagine this is the road here and imagine this is our truck wheel here. So as the wheel rolls along, you can see that any given point is just at rest for a moment in time as it comes in contact with the road. So again, imagine our point is this E right here for east. As it hits the ground, it does not slide like this. It comes in contact for a moment in time and then it rolls to the next point, which is in contact for a moment in time. So each point is actually just statically involved with the contact with the road there. That's if you switch to locking your wheels, then the tire will slide, and that is kinetic friction. That's actually why locking your wheels causes you to slide more, and is a bad thing to do. But now anti-lock brakes keep that from happening. So part E says, in a few short sentences, explain what happens to if the value of mv squared over r is greater than the value of mu times the normal force. So what this is we know that we are going in a circle. So that means that the sum of our forces have to equal mass times the centripetal acceleration. This side is what becomes mv squared over r. And this side is whatever is making us go in a circle. In this case, it's friction, so it's mu s times normal force. So if this value, either if our velocity gets too big or if our radius gets too small, then this side can get bigger than our friction can actually be. Our friction will always match this up until a point. This has a maximum value. So if this side winds up being bigger than this, then our friction is incapable of supplying a centripetal force. And if that is the case, then our car will not be able to simply turn like that, but it will slide out of the circle if there's not enough friction to push it into a circle there, because nothing wants to go into a circle. So last part here, which turn, left or right, requires the truck to slow down more in order to make the turn safely here? Explain your answer using the appropriate relationships. So, well, let's just use what we mentioned on the other page there, that mu s times the normal force is equal to mv squared over r. So this is a constant between the tires and the road, and normal force is a constant based upon the weight of the truck there. So this has a fixed value. It can't get any bigger than whatever it is. So over here then, we got to make sure this doesn't get too big. So look at the difference here. The right turn right there has a much smaller radius. Because radius is down in the denominator here, the smaller radius gets, the bigger the centripetal acceleration gets. So centripetal acceleration is inversely proportional to the radius. So smaller radius, greater centripetal acceleration, greater force. Or conversely, this right or left turn here has a bigger radius. So a bigger radius would correspond to a lower centripetal acceleration and a lower force of friction required. So that is why you always can take a wider turn more easily than a sharper turn. So this little checklist here, they just want to make sure if you'd actually written out the paragraph that you answered the question directly, you talked about what's going on there, that you stated a law of physics that's always true, the friction equation and the centripetal force equation. So you connected the laws of physics to the specific situation. Well, we did that with talking about the radii here. And then I used physics vocabulary, so, friction, radii, coefficients of friction, we used all of those terms right there. So we are good.